This is question 10 from the CCEA A2 Pure past paper from 2022. So let's take a wee look then at what's being asked. So it says figure 3 shows a graph of the parametric equation x is cos theta, y is sine 2 theta. Show that dy by dx is 2 cos 2 theta over sine theta. Well, we need to differentiate this given us dx by d theta. And if we differentiate that, we of course get minus sine theta. Then we need to find dy by d theta. And so we need to differentiate that, and that's going to give us then 2 cos 2 theta. Then dy by dx, which is what we've been asked for, is dy by d theta times d theta by dx. So dy by d theta is 2 cos 2 theta, and then multiplied by 1 over minus sine theta. And of course, if we bring that down to the top, we get 2 cos 2 theta all over sine theta, and I bring the minus then outside the front, which is what then they required. Part 2, determine the values of theta for the 4 stationary points. So to find the stationary points, we put dy by dx equal to 0. So remember what our dy by dx was. It was minus 2 cos 2 theta all over sine theta, and we're setting that, as I say, equal to 0. If we multiply through by sine theta, then sine theta can't be equal to 0, but we effectively have minus 2 cos 2 theta is going to be equal to 0, and that means we effectively then need cos 2 theta is going to be equal to 0. And where then is 2 theta going to be equal to 0? So where's cos equal to 0? We could maybe kind of take a wee look. They're looking for 4 stationary points. So cos theta is equal to 0 here and here. So that's going to be pi over 2. That's going to be 3 pi over 2. We then need to kind of keep going, and it's going to be 5 pi over 2, which would be the next one. I haven't really drawn it here, but I'll just kind of keep on going down to about there. And then our final one is 7 pi over 2. We're of course asked for the values of theta. So theta then is going to be divide everything by 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Hence find the exact Cartesian coordinates of the 4 stationary points. My goodness. So our first one for theta is equal to pi over 4, and if we go back to the original question, we're going to find cos of pi over 4, and we're going to give sine of 2 upon pi over 4, and that gives us then what we want. So our x value, as I said, is cos of pi over 4. We'll work that out in a wee second. And our y value is sine of 2 pi over 4. So that means x is going to be 1 over root 2. Again, checking your calculator, it's equivalent to 45. And then y is going to be 2 pi over 4, and it's just going to be 1. So my coordinate of the first stationary point then is 1 over root 2 and 1. Now some people like to rewrite this. I like to rationalize the denominator, so that then would be root 2 over 2. It's just the same number as 1. What we can do is just simply sub in our 4 different values for each of those. Let me see if I can kind of find them. So if you sub in 3 pi over 4, 5 pi over 4, and 7 pi over 4, you can get it, and that's just going to give you those 4. I'm not going to sit and do all that. The other thing weirdly you can do is kind of look at the original. So the stationary points are here, and here, and here, and here. Do you see the symmetry? So if we've worked out the first one, and it's root 2 over 2, 1, this is the one in the first quadrant there. So this one then is going to be 1 minus root 2 over 2. So you can kind of use symmetry or whatever way you want to try and work those things out. But the 4 values end up being, there's 1 there, and the next one then is minus root 2 over 2, 1. The next one then is root 2 over 2 minus 1, and then one then kind of with both minuses, minus root 2 over 2 minus 1. Hence find the exact Cartesian coordinates of the 4 stationary points. Find the Cartesian equation of the curve shown in figure 3. So we then need to go back. Let me save so many pieces of paper to try and work this out. So we have that, and we need to kind of join these together. So let's write out what we have and see if I can suss out what we're going to do. X is cos theta, and y is sine 2 theta. Now quite often you kind of square these and you kind of get a cos squared and stuff like that, but with kind of different ways of doing this one. So I'm going to go x squared is cos squared theta, and then I'm going to y squared. So I'm going to write y first of all as 2 sine theta cos theta. And then you could sort of sit and rearrange here then for the kind of cos squared theta, but don't quite get rid of it. And so we're going to square everything here. So y squared is 4 sine squared theta cos squared theta. And then we have a cos squared theta here, so I'm just going to change this to a 1 minus cos squared. So y squared is 4 1 minus cos squared theta cos squared theta. Y squared is 4 1 minus x squared upon x squared, and effectively then that's our Cartesian coordinate. You could multiply it out a little bit if you wished, but whatever way you want to sort it out. That's part 4. Part 5, below the area bounded by the curve, the x-axis and the line 0.5 then is shaded. This area is rotated 2 pi radians about x-axis, form a paperweight. Use your answer to part 4, find the volume of material needed to create the paperweight. So in this one here, we're going to use the formula V. Hopefully you can see, see if we can get this camera right so we can see kind of both here. It's the integral, and it's between 0.5 and 0, and it's going to be of y squared dx with the pi then out the front. So in this scenario we're going to have v is pi between 0.5 and 0. Now y squared, weirdly we have it kind of in the right form here. Look, we already have the y squared, so that's actually handy for us, and we just kind of need to multiply this all through. So it's going to be 4x squared minus 4x to the power of 4 dx. Let's see if we have a wee bit more space to continue this. We've plenty of space, so we're fine. So we're going to integrate this now. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and that's between 0.5 and 0. You folks will just kind of put that into your calculator now, kind of whatever way you want to work it out, but it's going to be V equals pi, and if you stick that in you get 17 over 120. So it's 17 pi over 120, or if you wanted the 3 significant figures or something like that, 0.445. That's then going to be cubic units. And that's us finished. That was a big question.